The other thing is that a lot of satellite IoT offerings is that, okay, we have a solution, we can, it's new, it's good, and we can integrate this module into OEM's devices. And OEMs are very conservative. If you want to have a new service into your device, they want to make sure this thing will last for years. Like the company offering that has the strong technical basis or is following some standard or have the growth rate that allows it to continue for years. And whatever is there is transportable. It's not you're depending on one provider and you put this in your device and whatever happened to that provider, then, you know, between day and night, that's it. All your assets are gone. So this is also another myth that a lot of people believe. Now, the other thing is that saying like, you know, IoT application require just few bits or few bytes of data, like some say 144 bytes per day, is all what IoT users need. They won't ask for more. This is not true. IoT users, with this low cost offering for services of IoT, users are getting more hungry for data. They would like to have more access to their assets, get all different types of parameters, and this will add up into the data size request of such customers. And with a system which is very limited, that is only able to provide few bytes per day or maybe few kilobytes per day, this will become also a bottleneck or a limitation on the attractiveness of the offers of the satellite operators. Other thing is that size doesn't matter for terminals. Indeed, it does matter. So having very small and compact terminals is important for IoT business. The same thing is with bandwidth. So having a wide bandwidth where you can have these million users addressed, where you can navigate the interference and the licensing over different countries is an important thing. The other thing is that when you look, you mentioned like cattle tracking, for example. A lot of applications, machine-to-machine communications existed already, like since a long time. There is already a global star animal tracking solution. Maybe the price difference is there's a price difference, but it's not huge. And it's a mistake that people think with this gap will never close between what legacy operators offer and what the new IoT provider trying to offer. So there must be a difference in the value proposed by satellite IoT operators, not just trying to redo what M2M guys are doing, but with a cheaper price and a small gap. So this is also an important thing. And the other big thing we always is like, the satellite IoT device battery can last for 10 years. You leave it 10 years and it's gonna stay there. Well, this is actually maybe true if your consumption is very limited. You have a contact of once per few days, but still it's a challenge also to meet such a requirement. So meeting this has to follow like a certain level of requirements. Then you can say something like that. The other thing is that security. So a lot of, when you look at the security part for most of IoT solutions, you see, okay, the AES encryption part. So you encrypt your data, the keys, and that's it, security is covered. But security is a very big topic, and it goes beyond that. And with such a huge network of millions of devices, security starts to become an issue. Now, I want to look here at a case study. Our company was trying to offer also satellite IoT based standard of 5G, and how we can take some of these myths and how we try to come up with a solution that can appeal as much as possible to the customer with realistic expectation. So if you look at this approach that we have in our system, what you have here is a system where the users have their mobile IoT devices that are normally connected to a mobile operator. And then once they move out, then they seamlessly are handed over and connect to this global satellite network using the same type of the Airlink. the same bands, and then the data is actually relayed back into a core network, which is compatible with the mobile network, a 5G core mobile network that other mobile operators can easily tap into. And this way, we have also like a synchronous system based on 2 dimensions, both on frequency and time, which is very hard to achieve on a LEO satellite system. However, this is what we managed to do, and this then unlocks for you the value of having really scalable system and large number of users that you can schedule into your system. So let's try to tick the box. So regarding myth 1, and I'll try to remember all the myths. Like building your own satellite, no, this is something we don't need. It's better to focus and outsource, constructing your satellite to someone else. Focus on the payload. Now, myth 2 about global standards. So when we say open, 3GPP standards are open. You can go to the 3GPP website. You'll see like these thousands of documents that describe how the thing works. If you're smart, read that and build it. And this is how the ecosystem evolves. There are multiple chip vendors, multiple providers of base stations, multiple operators. Now, when we say open, we have to look into all the layers. LoRa, for example, the LoRa itself is not open. The chip is made by only one company, and the firmware inside that chip is not open. Okay, the application and on top of it, and the one system, okay, that is available. But it is still similar to Sigfox. It's a proprietary technology. It's not a global standard. If you look also on, I can't remember what was number 3, but trying to build your ecosystem is actually a problem. That's why 3GPP is the global standardization body that put the 2G, 3G, 4G, 5G. They are looking into non-terrestrial network, 5G, new radio, NB-IoT. We are part of it. We're very proud to be part of the global ecosystem, working side by side with mobile operators and big satellite operators, and presenting all our experiments that we did in orbit regarding narrowband IoT. The other thing regarding depending on others, of course, the nice thing we have is that we own the IPR of the base station payload software. So we built a cellular base station software that can run on SDR on a satellite with low power and process the signal of users. And we can optimize the scheduling and the way we handle traffic for the user to give the best experience. The other thing is that our system can scale up easily into other satellite networks. So if we find another satellite where we can put our payload on, or a programmable payload that we can upload our software on, then we are able to provide the service. We are not here into the infrastructure as per se business. What's interesting also, we discovered that our user terminals can even connect to GEO operators, and we can have our base station hosted at the GEO operator hub. So, and this actually helps us a lot to expand, especially in regions where we have no access to or no licensing, and work side by side to have a system based on both LEO, GEO, maybe MEO, where you have global ubiquitous 5G IoT connectivity. Regarding the frequencies and the bandwidth, so we're looking here at a wide bandwidth, which is the S-band, where you have a lot of megahertz, and you can always coordinate and navigate where your users will be. And the technology is very scalable by its nature also, because it's a synchronous system from the 5G based on FDM. The other thing is that we work with licensed bands. So in order to guarantee high quality of service, reliable service for user, you need to operate on licensed bands. You have a barrier to entry, and you work together with operators and coordinate with them, and not just in a band where everyone can access. You have interference, collisions, and you try to build business on that. Now, so our technology is following. So if I go back to number 9, I'll try to remember this. So number 9 was. Yeah, okay. So this is important. I mean, when you look into like if you try to certify your module or sell this module to OEMs, you're basing yourself on a standardized technology which is known for the customer, which is tested with thousands of hours of engineering and users, which is there are different players in the field. So this actually gives confidence that for OEMs that whatever products is there will be other providers, and it will last also for a long period of time, and it's something that it's not proprietary with only one provider. Regarding the data, so the nice thing with 5G is that you can, based on the data requirement of your customer, schedule him in the right blocks, so we can go up even to megabytes per day of data, which other satellite IoT operators cannot do. And this opens the door for a lot of other applications, even like voice or low resolution images. Size, I mean, currently our terminals, they are like 10 by 10 centimeter, but this is covering a wide band of like 65 megahertz. So once these are used now for prototypes and testing, once is defined exactly where the band will be, the antennas will be even smaller. This is like an example of the terminal, which and the board and the antenna embedded, the S-band antenna that is compatible with 5G narrowband IoT. So if I go, the bandwidth that I said, like in the sub 6 gigahertz bandwidth, especially in the S-band, there is a wide band that can be used and accommodate large number of users. And then, let me just remember this number 13. Yeah. Okay. So now, one of the very unique things that we have is that I've looked into what exists today that offers a dual mode satellite terrestrial. I've seen some very expensive terminals from Cobham and others. I haven't seen something which is low cost and providing both cellular and terrestrial. What we have is very unique. We are talking about the same cellular chip that cost a few dollars is able to do today both satellite and narrowband IoT. This have never existed before. You have to have a satellite modem, which costs a lot of money, and a cellular chip, which is low cost. So this is actually the unique proposition that we have. So regarding battery power and all this, of course, it's when you look into what power you use and the recommendations that are available in the 3GPP standard, then you can easily calculate and know how much the battery of your user terminal will survive based on your power consumption. There's nothing hidden is that. And finally, regarding like security, this is the nice thing. It's already standardized and exists. The security layers, the authentication, the way SIM cards work, it's all standardized and out there and tested, and you just embed that into your system. So you don't need to reinvent the wheel, and you don't need to just add simple encryption or something and say my system is secure. So these are really where we look to tick the boxes of these myths to provide something very attractive. Our vision really is to make every smartphone in future and IoT device now speak the same language as satellites and have a global ubiquitous 5G IoT connectivity. Thank you very much. I'll leave also my email contact and phone. We are very happy to work with partners, infrastructure providers, but also end customers.